Question 3 is really trying to test your understanding of the equation of a straight line, and indeed, if you're given the point on a line, how you go about finding the equation of a line which is perpendicular to the initial line. So, in part A, we are given this line here, and we are told that it has the equation 2y minus x minus 7 equals 0. And we are asked to show that the point A with coordinates 1, 4 lies somewhere on this line L1. So in order to do that, it's going to be fairly straightforward. All we're going to do is take our values of x and y and substitute them into this equation. So we're going to do 2 times y minus x minus 7 and see what we get. So if we get 2 times 4, we're going to get 8 minus 1 is 7 minus 7. That does give us 0. Therefore, because it equals 0, it must be on the line. So we can mark on the point here A as 1, 4. In part B, we are told that the point C has coordinates 5, 12, and that the point M is the midpoint of AC, and we're asked to find the coordinates of the point M. So to do this, you can just do it intuitively, recognizing that the x coordinate of the midpoint will be halfway between here and here, which is going to be 3, and the y coordinate is going to be halfway between here and here, which is going to be 8. Or if you want to use the formula, you can use the formula x1 plus x2 divided by 2, so the mean of the x values, and then the y coordinate is going to be the mean of the y values. So that is also going to more formally give us the answer, so that's going to be 6 over 2 brackets 16 over 2, which also gives us 3, 8. Part C asks us to find the length of AC. So the simplest way of doing this is recognize that we can interpret this as a right angle and just a right angle triangle and use Pythagoras to find this length. So the way that we can find the base of the triangle is going to be look at the difference between the two x coordinates. So we're going to have a base of 4, and we're going to have a height similarly looking at the difference in the y coordinates of 8, and then we're just going to use Pythagoras. So AC squared is going to be 4 squared plus 8 squared, so it's going to be 16 plus 64, so that's going to be root 80, which is going to give you approximately 8.94. Part D is where it starts to get interesting. We are told that there is a second line L2 which is perpendicular to AC and passes through M. So we've got something like this, and we are asked to show that the equation of the line L2 is 2y plus x minus 19 equals 0. So there are two ways that we can go about approaching this, but they both require us to know in the first instance the gradient of the line AC. So in order to work out the gradient, we've already worked out the distance between these 2 points in the previous question. So we figured out in part C that the base of this triangle here was going to be 4 and the height was going to be 8. So the gradient of AC, so the gradient is going to be 8 over 4, which is equal to 2. Now, we need to recognize that when we have two perpendicular lines, so lines, straight lines at right angles to each other, there is a relationship between those two gradients, such that the gradient of the first line multiplied by the gradient of the second line equals -1. So we can rearrange this and find the gradient of the second equation by taking -1 and dividing by the first gradient. So we have established over here that the gradient is 2. So the gradient on the second line, which we're trying to find out here, must be equal to -1 over 2. So we know now that the gradient of this line is going to be -1/2. So from here, as I said, there are two different ways that you can go about finding the equation. So I'll just run through them both. The first one tends to be more popular. So we know that the equation of the straight line is y equals mx plus c in general. And we know that it goes through the point 3, 8. And we also know that the gradient is -1/2. So we know y is going to be 8, m is the gradient, which is -1/2, and x is 3. So the only thing we don't know in this equation is c. So we can substitute in here, and we get 8 equals -1/2 times 3 plus c. So we can rearrange that and solve to get c equals 9.5, and then we can just rearrange. We can rewrite the equation of the straight line here with all the variables now that we solve for c, and we end up with y equals -1/2 x plus 9.5, and we can see, bearing in mind that we are asked to show this is the equation of the straight line, we can see that if we bring all this over to one side, we're going to end up with y plus 1/2 x minus 9.5 equals 0, and if we just double that, multiply both sides by 2, we'll end up with 2y plus x minus 19 equals 0. The second way that we can do it more directly is just to use the formula y minus y1 equals mx minus x1. So if you substitute in here again, so it's going to be y minus 8 equals -1/2 brackets x minus 3. So if you expand that out, that will also give you this equation here, and then we can also continue as we did here to show that the equation of the line perpendicular to L1 is 2y plus x minus 19. In part E, you are asked to find point D, which is the intersection between L1 and L2. So there's a number of ways you could do this, but essentially what you need to recognise is that at the point D, where these two lines intersect, this and this will take the same value. So one way you can do this is just set these two equations equal to each other, and then solve. So you'll get, if we rearrange and simplify, we'll get 2x is equal to 12, x is equal to 6, and then we can, if we substitute that back into one of them, so if we say 2y minus 2x minus 7 equals 0, that's the first equation here. If we now rewrite that and say 2y is equal to x plus 7, we said that x here is 6, so we can say that's going to be the same as 6 plus 7, which is equal to 13. So if that's 2y, then y is going to be equal to 13 over 2, which is 6.5. So therefore, the coordinates of point D are going to be 6, 6.5. Now, you could also do this graphically. You could plot both of these equations and find the intersection, or we could do it with simultaneous equations on a calculator as well. Part F is a slightly unusual question. You're actually asked to give an answer to 5 significant figures. However, it's actually fairly straightforward. If you plug this into your calculator, you'll end up with something that looks like this. You're asked to round it to 5 significant figures. So this is the first, second, third, fourth, fifth significant figure. So you would then have a look at the next number. So we can see that the next number here is 0, which is less than 5. So therefore, we're not going to round up. And then that is going to be our answer. In the final part of the question, we are told there is a point B such that ABCD is a rhombus, and we are asked to find the area of the rhombus. Now, we don't actually need to know the coordinates of B. All we need to know is that it's a rhombus, and therefore we can recognise that the area, well, we can use symmetry to find the area. So earlier on in the question, we found the length of AC. We found that AC, length of that was root 80. So we know that AC is root 80, and we are also told in part F that the length MD from the midpoint of AC to D is root 45 over 2. So we now, just looking at this triangle here, have got the base and we've got the height. Because this is a rhombus, we can work out the area of this triangle and multiply it by 2. So in order to do this, we are going to work out that area, which is going to give us 2 multiplied by the area of the triangle, which is going to be half AC, which is root 80, times MD, which is going to be root 45 over 2. That is going to cancel out with that, so all we're going to end up with is root 80 multiplied by root 45 over 2, which is going to give us 30.